Okay, guys. Most important thing you can do on a daily basis is just show up. Today's not an easy day. Definitely to your benefit that you're here right now. So we're we're going to look at a couple examples today, probably about four. I don't know exactly what the future is going to look like here, but again, your next test is open note, open homework, open study guide, and right now we'd be tentatively looking for a week from next Tuesday. A week from next Tuesday. So let's look at this example. Great example. This is definitely an example, one you'd see on the AP exam, probably actually more the next one. So airplanes traveling east at 600 miles an hour. Struggling today. So east at 600 miles an hour. Another is traveling north at 750 miles an hour. If they left the airport at the same time, how fast is the rate of their distance apart increasing after 2 hours? So we're wondering kind of that distance piece. So I need to figure out some things. Okay. First of all, can somebody here come up with a formula that I put into that box? Thank you. A squared plus B squared is C squared. Or I will call it E squared plus N squared is equal to D squared. E squared plus north squared is D squared. We all good with that? Now, what do we know? I know E prime. What is E prime? What's N prime? I'm looking for D prime. Does everybody agree? Well, let's take the derivative with respect to time of E squared plus N squared is D squared. And as I do that, what's the derivative of E squared? 2E E prime. Plus, what's the derivative of N squared? 2N N prime is equal to 2D D prime. Awesome. So that's what I have. What's interesting here, though, is that I have E prime. I know E prime, but I don't know E. E represents what? It's not the rate. It's the actual distance. So if they've been flying for 2 hours, what is the distance that the plane has traveled? 1,200. 600 miles per hour, 2 hours, 1,200 miles. How far is the train, or how far is the plane traveled north? 1,500. I'm looking for D prime. D popped up as well. Can you find D? How could you find D? By using the Pythagorean theorem. Yeah, so I'm going to take out my handy dandy calculator. I'm going to turn that guy on. Ooh, wow, tough day in college algebra. So we got 1,200 squared plus 1,500 squared. Is that my answer? Square root. The answer, and I get 1,920.94. So now I have enough pieces to put in place to solve for D prime, don't I? Yeah, it is. It's kind of bulky here, but we got 2 times E is 1,200 times E prime is 600 plus 2 times 1,500 times 750 is equal to 2 times D prime. So Whatever, you guys do what you want. If I'm doing the problem, I immediately get rid of the 2's. I just divide 2 off of everything, right? Divide by 2 and it's gone. So that way I'm less likely to make a mistake if I just divide through by 2. So I'm going to have to add those 600 times 1200 plus the insert. Yes, I've made many mistakes today. Plus, thank you. And I get that, and I divide that by 1920.94. And I get 960.47. What? Miles per hour. Now, I'm worried you guys are gonna like start yelling and throwing stuff at me. Just watch this. If I take 750 squared plus 600 squared, and I take the square root of the answer, look at what I get. Right. So here's why. This problem is a setup problem. It's to help teach you how to do the next one. It's to help teach you how to do the next one. Here's the deal. The AP exam, they wouldn't give this problem anymore. They wouldn't give this problem because people would simply do that, even though it's really not the correct way of going about it. So we have another very similar example right here. The difference is that shortcut piece does not work. A ladder that's 12 feet long is sliding down the side of a building. So I've got this building, got a ladder, it's 12 feet long. The base of the ladder is moving at a rate of 1 foot per second away from the wall. How? There's nobody on the ladder, but there is a cat below the ladder we're trying to hit. Yeah, a bag of leaves below the ladder. So the top, everybody agree the top of the ladder is dropping? Top of the ladder is dropping. How fast is the top of the ladder falling when the base of the ladder is 10 feet from the base? So this distance is 10 feet. Okay? Actually. All right, here we go. So I'm going to call that x as in horizontal. I'm going to call the vertical y. And you can see that I have x squared plus y squared is what? 144. Does everybody agree that what's different about this problem is the hypotenuse is not changing? See how this part is constant? That's not changing. So because it's not changing, you can plug in the 12 right away. And that's a good thing because the derivative of a constant is 0. So I'm going to list these things: x, x prime, y, y prime. These are obviously the pieces that will be in place. Which one of these things do we currently know? I know x, it's what? 10. And I know x prime is 1. So I need to determine which one of these am I looking for? Because it's moving 1 foot per second away from the wall. The rate of the horizontal movement is 1 foot per second. No, that's what we want to find. Can we find y? How? Yeah, you plug in 10 and you get 100 plus y squared is equal to 144. Or y is equal to the square root of 44, or 2 roots of 11. We good? So let's take the derivative with respect to time. Do you understand that that's the whole idea? Related rates. They are all rates related to time. So I have x squared plus y squared is equal to 144. What's the derivative of x squared? 2xx prime, derivative of y squared is equal to 0. It is. So I get 2 times x is 10. Sorry. 10 times 1 plus 2 times 2 roots of 11 times y prime is equal to 0. Don't do that because that's a mistake that people made on their last test. I get 20 plus 4 roots of 11, y prime is equal to 0. Or y prime is equal to negative 20 over 4 roots of 11. Or y prime is negative 5 roots of 11 over 11. And what is the label? Feet per second. Do you see the slight nuances? That's where it's so important to pay attention, folks, because the test, you're going to have to rely on that. Good. You're doing well. Okay. Okay. Let's try the tough problem. Yep, it's time. Time to try the tough problem. We got 2 more problems in us today. That's what we can kind of get through. My goal is, I think Monday I would do 1 problem with you. You'd be given the rest of the time to work and ask questions. Lesson on Tuesday and Wednesday, because those are the last days I'm here. Thursday, AP review day. Friday, time for you to work. I get back on Monday, time for you to work and ask questions of me. Tuesday test. I have a math conference. This is a good time. Let's do it. We got corn. Corn's being empty. It's like right in the middle of harvest time. Corn's being emptied out of a pile, so it makes like a cone, right? It's being emptied onto at a rate of 12 cubic feet per minute. What type of measurement is that? Volume. Yeah. And it's taking the shape of a cone. How fast is the height of the pile increasing when the pile is 6 feet high and has a base diameter of 8? This is a moment where we need to be able to see, do we truly understand what's going on? There's a lot of nuances to this problem. First of all, what formula do I need? Volume of a cone is 1/3 pi r squared h. Identify in the problem what's changing. Height, base, radius, volume, like everything's changing, agreed? So does everybody agree if everything's changing? I can't plug in the 6 right now. I can't plug in the 4 for the radius right now. It's all changing. So what do we do? Now, let's list what we do know. We do know that the V prime is what? 12. And we do know that the current radius is 4. And we do know that the current height is 6. And what are we trying to find? H prime. This requires you to think ahead a little bit. Let's look ahead in the problem. Right now, if I were to take that derivative, what rule would I have to use? The product rule. And if I use the product rule, true or false, I will come up with an R prime. True. And I will come up with an H prime. I want the H prime. I don't want the R prime. I got no way of finding the R prime at all. None. So I got to get rid of it. How do we get rid of R? We can't simply plug in 4. Then we come up with D prime. So here's the deal. This cone is going to continue to get bigger and bigger and bigger, right? And it will grow in proportion. So look at what we have. If you take the radius divided by the height, what is the current radius? 4. What is the current height? 6. Or the radius over the height is always 2 over 3. Or the radius is always 2/3 the height. What can I do with this? And if I do that, I get the volume is equal to 1/3 pi times, what do I get if I square 2/3 h? What do I get if I square 2/3 h? 2/3 h times 2/3 h. 4/9 h squared times h would be h cubed. So the volume is equal to 4/27 pi times h cubed. That's my new formula in terms of just h. Riker. Volume is 4/27 pi times h cubed. Take the derivative with respect to time. Derivative with respect to time, what do you get? V prime is 12/27, which reduces to 4/9. 4 pi over 9, then what? H squared, H prime. So, let's solve. What is V prime? 12 equals 4 pi over 9. What is the current height? 6. So times 36 times h prime. Where 12 is equal to 36 over 9 is 4, so 16 pi h prime. If I divide by 16 pi, looks like you get h prime is 3/4 pi. What's the label? Feet per minute. Last example for the day. Sorry. and then the study guide, and the time to practice on the test by watching. But folks, just I want to be clear that I mean, if I change the problem, suppose I don't give you when the pile is 6 feet high or base diameter 8. Suppose I change the question, how fast is the radius of the pile increasing? Well, then you would have to just do a slightly different formula, right? I'm not going to give you the exact same question. You do understand that, right? You're going to have to understand a slight nuance. I mean, I just got to understand the problem. Can't just. So. Okay, last example. Street light is mounted on top of a 20-foot pole. This is nowhere near as difficult as what we just did. Street light. A man is 5 feet tall. He's walking away from the pole. He's walking away at a rate of 4 feet per second. How fast is the tip of his shadow moving when he is 30 feet from the pole? What's new about this is the structure of the problem. It's the formula that we use. Immediately, you are drawn towards certain formulas, and they may or may not work. Does anybody see what we set up here? Looks like the Pythagorean theorem. You want to, but you don't. Because we are not concerned at all about the hypotenuse, nor do we know anything about the hypotenuse. Does somebody see the geometrical representation that we have here that we can use? How many triangles do you have? Are they similar? Yes. Yeah. Do you see that you have the red triangle and you have the blue triangle? They both have what kind of angle? Right angle, and they have a shared angle, correct? So if two angles are the same, then the third angle is the same. And if shapes have angle, 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 they are similar, and similar shapes are proportional. It's okay. It's okay. You know what? We appreciate that you're trying and you haven't been here. So good job. Yeah. So I'm going to talk about the height divided by the length. Okay? Let me set it up like that. So what is the height of the pole? 20 over, what's the length of the pole? Or I'm sorry, what's the length of the shadow? So we've got 30, right? But then we've got, that's the rate. We don't actually know how long his shadow is right now, do we? So I'm going to use S to represent the length of the shadow. So what expression would we use for this entire length here? 30 plus S is equal to, what's the height of the man? 5 over S, his shadow. Okay, so let's cross multiply. And when we cross multiply, we get 150 plus 5S is equal to 20S. So I get 150 is equal to 15S. Correct? Divide by 15. Okay, YouTube, I'm really sorry about that. I just explained that we never actually looked at what's changing the problem. I fell into it. It's my bad. The height of the pole is not changing, so it's 20. The height of the man is not changing, so it's 5. And the length of his shadow is S. But what is changing is his distance from the pole. I never should have plugged in 30. I plug in D plus S. And so I went down a bad path. I made a mistake. I caught the mistake. Um, so I'll feel a little bit better about that. We still cross multiply. 5D plus 5S is equal to 20S. Or 5D is equal to 15S. So D is equal to 3S. We have a formula. It's pretty simple. We need to come up with some rates. So let's take the derivative with respect to time of D equals 3S. What is the derivative of D? D prime. What is the derivative of 3S? 3S prime. At what rate is he walking away from the light pole? 4. So we have 4 is equal to 3 times S prime. So while the answer looks like it's 4/3, understand that he is moving at a rate of 4 feet per second from the pole, and then the shadow is moving at a rate of 4/3 feet per second from him. So as we combine those, we take 4 plus 4/3, or 12/3 plus 4/3, and we get 16/3 feet per second. That is a classic AP problem. Good work.